Welcome to Elephanta Insights. Right now, something is happening in the Pacific Ocean that most people will never notice. But the effects can travel across the world. Somewhere in the tropical Pacific, a patch of ocean begins to warm. Just a degree or two. Not enough to feel if you were swimming in it. But this patch, roughly the size of Europe, is about to rewrite the weather for the entire planet. It will change where rain falls and where it doesn't. It will parch rice paddies in Southeast Asia, drown coasts in South America, and push local extremes of heat and humidity into ranges approaching the limits of human survival. It will distort food prices on the other side of the world. It will force central banks to make impossible decisions. It will reshape geopolitical alliances. All of this from a patch of warm water. To understand why a patch of warm water can do all this, you first have to understand how the tropical Pacific normally works, because it is the engine room of the planet's climate. Under normal conditions, steady easterly trade winds blow from the coast of South America toward Indonesia, pushing warm surface water into a massive pool in the western Pacific. This creates a powerful east-west temperature gradient. The western Pacific is bathed in deep, warm surface water and generates the strongest year-round band of rain and convection on Earth, while the eastern Pacific, near Peru and Ecuador, stays cooler as nutrient-rich water rises from below, a process called upwelling, that sustains some of the world's richest fisheries. In the atmosphere above, a circulation cell called the Walker circulation completes the loop. Air rises over the warm western Pacific, flows eastward high in the atmosphere, descends over the cooler eastern Pacific, and returns west along the surface as those same trade winds. It is a self-reinforcing system. Stronger trade winds mean more upwelling, a stronger east-west temperature difference, and a stronger circulation. This is the neutral state. This is what normal conditions look like. But every 2 to 7 years, something disrupts this balance. The trade winds weaken, sometimes triggered by westerly wind bursts or subsurface waves of warm water moving eastward across the ocean. When that happens, the warm pool that normally sits near Indonesia begins to slosh back towards South America. The temperature gradient across the Pacific flattens. Convection and rainfall follow the warm water eastward. Upwelling off Peru shuts down. This is El Niño. When sea surface temperatures in the central eastern equatorial Pacific exceed about 0.5 degrees Celsius above normal for several consecutive seasons, scientists formally declare an El Niño. Most El Niño events are moderate, significant enough to shift weather patterns, but manageable. But 3 times since modern observations began in 1982-83, 1997-98, and 2015-16, the ocean did something far more dramatic. Sea surface temperatures surged past 2 degrees Celsius above normal. The trade winds nearly collapsed. The Walker circulation reorganized so profoundly that the climate anomalies it produced were not just stronger but qualitatively different. These rare events are often called Super El Niños. They are not an official scientific category. The technical term is very strong El Niño, but the difference matters. These events reorganize global circulation in ways that moderate El Niños simply do not. And right now, in mid-2026, international forecasting centers are watching the Pacific with growing concern. Now, to understand what a Super El Niño actually does to the world, look at 2015 to 2016. The most recent of the 3 Super El Niño events, and the best documented. It began in the spring of 2015, when sea surface temperatures in the Niño 3.4 region began rising rapidly. By winter, they had hit anomalies comparable to 1997 to 1998. The tropical Pacific had essentially rewired itself. The consequences arrived in different forms in different places. Indonesia and parts of Southeast Asia dried up, drought and wildfires consumed peatlands and forests, sending haze across the region. Australia grew hotter and drier, droughts set in, and bushfire risk climbed. In East Africa, the pattern flipped the other way, heavy rains and flooding. Along the west coast of South America, Peru and Ecuador were deluged. But the most profound effect of 2015 to 2016 was on global temperature. That Super El Niño, layered on top of ongoing anthropogenic warming, helped push the planet into record-breaking warmth. The year 2015 shattered previous global temperature records. 2016 shattered them again. And the heat did not stay in the Pacific. In South Asia, the heat arrived with lethal force. The 2015 heatwave, during a period when developing El Niño conditions combined with long-term anthropogenic warming, killed roughly 3,500 people in India and Pakistan over just a few months. It ranks among the deadliest heatwaves ever recorded. And the heat did not just kill directly. It stressed crops, dried up reservoirs, and pushed an already vulnerable agricultural system toward its limits. In India, the summer monsoon that year delivered only about 86% of its long-period average, and this came after a 12% deficit in 2014, creating one of the few periods in recent history with back-to-back weak monsoons. Rice output dropped by an estimated 3 to 4 million tons. Pulse production collapsed so badly that pulses inflation surged past 30%. Consumer price inflation climbed to around 4.9%, and that was just the official average. The 2015-16 Super El Niño did not cause a famine. It did not collapse the Indian economy. But it demonstrated something essential. Even with modern forecasting, modern infrastructure, and modern markets, a very strong El Niño still had the power to disrupt food production, destabilize prices, and kill thousands through heat alone. Why is India among the most vulnerable countries to Super El Niño? The answer runs through the monsoon. Between June and September each year, the southwest monsoon delivers about 3/4 of India's total annual rainfall. This single seasonal pulse feeds the Kharif crop cycle: rice, pulses, oilseeds, cotton, sugarcane, recharges reservoirs, replenishes groundwater, and sustains roughly half of India's cultivated land that remains entirely rain-fed. Since 1950, 16 El Niño events have occurred. 7 of these were associated with major monsoon deficits, or outright droughts. Since 1980, roughly 70% of El Niño years have brought below normal monsoon rainfall to India. The 4 most severe drought years since 1980 to 1982, 1987, 2002, and 2009 were all El Niño years. But the relationship is not absolute. In 1997, a very strong El Niño did not suppress the Indian monsoon at all. The difference came from the Indian Ocean itself. The Indian Ocean has its own temperature oscillation called the Indian Ocean Dipole, the IOD. When the Western Indian Ocean is warmer than normal, a positive IOD event, it tends to support monsoon rainfall, counteracting El Niño's drying effect. That is exactly what happened in 1997. The positive IOD essentially cancelled out the El Niño, and the monsoon delivered. But in years like 2002 and 2009, the IOD was neutral or negative. Without that counterbalance, El Niño's influence on the monsoon was devastating. When the monsoon falters, the chain of consequences runs through every layer of India's economy. Rice, highly water-intensive, sees yield losses of 4 to 11% globally, with Indian production dropping by an estimated 3 to 4 million tons in strong El Niño years. Pulses, grown largely under rain-fed conditions in central and western India, are acutely sensitive. In 2015 to 16, pulses inflation exceeded 30%. Cotton yields in rain-fed regions of Maharashtra, Telangana, and Gujarat have fallen by 10 to 15% during past strong El Niño episodes. Oilseeds, soybean, groundnut, mustard declined by 5 to 10%. And the chain continues. Reduced reservoir inflows mean less irrigation water for the winter rabi crops, particularly wheat, which depends on water stored during the monsoon. Groundwater levels drop, forcing farmers to drill deeper wells at higher energy cost. Hydropower generation falls just as rising temperatures drive up electricity demand for cooling and pumping, forcing greater reliance on coal and gas. Each percentage point of monsoon shortfall relative to the long-period average reduces agricultural gross value added growth by roughly 0.3 to 0.4 percentage points. When agricultural output stagnates or contracts, rural incomes fall, distress migration to cities rises, and food inflation ripples through the entire economy. The Reserve Bank of India and other analysts estimate that weak monsoons linked to El Niño can push CPI inflation up by 0.4 to 1.5 percentage points above baseline, driven by cereals, pulses, vegetables, and edible oils. And food and beverages still account for around 37% of India's consumer price basket. Central banks must then choose between controlling inflation and supporting growth, sometimes tightening policy in response to food shocks even when the rest of the economy is slowing. But the story does not end with crops and prices. There is a more direct way Super El Niño harms people: through heat itself. Heatwaves across South Asia have become more frequent, longer, and more intense in recent decades. Scientific attribution studies link a substantial portion of this trend to anthropogenic warming. When a Super El Niño unfolds in an already warm climate, the combination can push local temperatures and humidity into ranges that test the limits of human physiology. The key measure here is something called wet bulb temperature, which combines heat and humidity to measure the body's ability to cool itself through sweating. When wet bulb temperature stays above about 35 degrees Celsius for sustained periods, even a healthy person cannot survive more than a few hours outdoors without artificial cooling. Some research suggests the real-world survivable threshold may be even lower, between 26 and 34 degrees for young adults, and 21 to 34 degrees for the elderly. Under high-emission scenarios, climate projections show large parts of the Indus and Ganges river basins could experience wet bulb temperatures approaching or exceeding that 35-degree threshold during extreme events by late in this century. El Niño-linked heat spikes will periodically test these thresholds decades before they become the norm. They offer previews, glimpses of what future habitability constraints may look like. And it is not just rural populations at risk. Urban areas in India experience additional warming from the urban heat island effect: concrete, asphalt, sparse vegetation, waste heat from vehicles and industry. Outdoor workers, construction laborers, street vendors, sanitation workers, agricultural laborers, delivery personnel are disproportionately exposed, and often lack access to cooling, rest breaks, or social protection. Heat action plans in cities like Ahmedabad and Hyderabad have shown that measures like cool roofs, early warnings, and adjusted work hours can reduce mortality and lower indoor temperatures by 2 to 5 degrees Celsius. But coverage remains deeply uneven. The chain does not stop at India's borders. It does not stop at the end of the growing season. Super El Niño sets off a cascade that flows through globalized trade, energy markets, geopolitical alliances, and finally into the domain of national security. When a Super El Niño triggers drought in major food-producing regions, the first geopolitical response is often what analysts call food nationalism. During recent El Niño and drought episodes, major rice-exporting countries including India and Vietnam imposed export restrictions to stabilize domestic prices. Wheat exporters like Russia did the same. These restrictions tighten global markets and push up prices for import-dependent countries, many of them in Africa and the Middle East, countries that had nothing to do with the Pacific temperature anomaly that started the entire chain. And in 2026, this cascade is no longer theoretical. As the US-Israeli war with Iran drags through its third month, attacks on energy infrastructure and shipping have choked traffic through the Strait of Hormuz, a narrow corridor that carries a significant share of the world's crude oil and liquefied natural gas. Global oil prices have surged, at one point jumping more than 25% in a single session, with Brent crude briefly trading at levels not seen since 2022, and analysts warning that prices could remain elevated or even climb higher if the disruption persists. For India, which imports close to 85 to 90% of its crude oil, this is an immediate shock. Higher fuel costs are already feeding into transport and food prices, widening the current account deficit and putting pressure on the rupee. Indian analyses warn that if oil averages around $100 a barrel for a year, growth could slow and inflation could spike even before the full impact of El Niño on the monsoon is felt. At the same time, the Reserve Bank of India is watching the sky. The 2026 southwest monsoon is forecast to be below normal, with a developing El Niño increasing the risk of weaker rains just as global energy prices soar. India is already facing a double bind, a war-driven oil shock on one side, and a climate-linked monsoon risk on the other, both converging on the same variables: food prices, energy security, and social stability. The energy dimension compounds the crisis. El Niño-linked monsoon shortfalls reduce hydropower generation, forcing India to increase reliance on coal and natural gas at the very moment when high temperatures drive up electricity demand for cooling. Weaker monsoons can raise India's coal, LNG, and oil import bills directly, linking ENSO to energy security and trade balances. Thermal power plants themselves need large volumes of cooling water, and during droughts, they compete for that water with cities and farms. And then comes the migration. When repeated El Niño-linked droughts erode rural livelihoods year after year, people move to cities, across state borders, sometimes across international boundaries, straining urban infrastructure and social services. In the most fragile states, clusters of climate shocks interact with existing grievances over land, water, and governance to heighten the risk of unrest. Food price spikes and water shortages can undermine government legitimacy, fuel protests, and influence electoral outcomes. Central banks and finance ministries in India, China, and other major economies now explicitly track ENSO outlooks when assessing inflation and growth risks, recognizing that climate variability can translate directly into political pressure. The major security institutions of the world have not missed this. NATO, in its Climate Change and Security Impact Assessment, describes climate change as having a profound impact on allied security as a threat multiplier that fuels tensions, instability, and conflict. The U.S. Department of Defense's 2023 Defense Science Board report identifies climate change as one of the most significant threats to global security, noting risks of new conflicts over water, food, and energy. Super El Niño is the shock that makes these abstract threats concrete. It compresses a slow-burning geopolitical trend into a single year of crisis. The report sketches three possible futures between now and 2050. In the first scenario, roughly aligned with strong global mitigation, keeping warming well below 2 degrees Celsius, ENSO remains active, but changes in its frequency or intensity remain relatively limited. Global warming still amplifies the impacts of El Niño, but societies are better prepared. Climate-resilient agriculture becomes widespread. Heat action plans expand into thousands of cities. Crops become more drought-tolerant. Reservoirs are managed more intelligently. Weather forecasts improve, giving governments weeks or even months to prepare for disruptions. In this future, Super El Niño remains dangerous. But it is no longer catastrophic. Human vulnerability declines faster than climate risk grows. The second scenario is less optimistic. Global warming reaches roughly 2.5 to 3 degrees Celsius by the middle of the century. Scientific uncertainty remains over whether El Niño itself becomes more frequent, but there is much greater confidence about something else. Every El Niño now unfolds on a significantly warmer planet. That means stronger heatwaves, more intense atmospheric moisture, higher rates of evaporation, greater stress on crops, more severe wildfire conditions, and more people living in places where extreme heat becomes a recurring threat to health, labor productivity, and infrastructure. The same climate oscillation that once caused inconvenience now produces disasters measured in hundreds of billions of dollars. Food systems become increasingly fragile. Insurance markets begin retreating from high-risk regions. Governments spend larger shares of their budgets responding to emergencies instead of preventing them. The cost of adaptation rises every decade. Then comes the third scenario. Global emissions remain high. Average temperatures climb beyond 4 degrees Celsius by late in the century. Whether or not Super El Niño events become more common almost ceases to matter. Because every Super El Niño now occurs in a climate unlike anything human civilization has experienced. Extreme rainfall becomes capable of overwhelming infrastructure designed for 20th century weather. Droughts become longer and hotter. Crop failures occur simultaneously across multiple continents. Heatwaves push outdoor work into dangerous territory for weeks at a time. Some regions experience combinations of temperature and humidity that make prolonged outdoor exposure physically impossible without cooling. Food security becomes inseparable from national security. Climate migration accelerates. Competition over water intensifies. Military planners increasingly find themselves responding not only to armed conflicts, but also to cascading humanitarian emergencies driven by climate shocks. The difference between these three futures is not whether El Niño exists. It always will. The difference is the world into which El Niño arrives. It is tempting to think of climate change as something gradual, something measured in decades, something that advances one fraction of a degree at a time. But Earth's climate does not always change gradually. Sometimes it changes in sudden pulses. A Super El Niño is one of those pulses. It takes the slow accumulation of greenhouse warming and concentrates its effects into a single year. A year of failed harvests, record heat, floods, wildfires, economic shocks, political instability. Not because it creates a new climate, but because it exposes the one we have already built. The Pacific Ocean does not care about national borders. It does not distinguish between rich and poor. The atmosphere connects every continent through a single circulation system. A disturbance that begins thousands of kilometers away eventually reaches farms in Punjab, reservoirs in Karnataka, factories in Guangdong, ports in Peru, financial markets in New York, and dinner tables almost everywhere. That is the defining lesson of Super El Niño. In the 21st century, there are no local climate events. Every major disruption becomes global. Every economy becomes connected. Every government inherits the consequences. And every year, somewhere in the tropical Pacific, scientists watch the same stretch of ocean, looking for the first signs that the engine room of the planet is beginning to shift once again. Because when it does, the entire world moves with it. But here is a question to leave you with. If a single patch of warm water can reshape the world's food, heat, energy, and politics in 1 year, what does that mean for the kind of world we are building for the next one? Think about it. And tell us your answer down below in the comments. We read every one. If this opened your eyes to how much the planet's climate is already shaping our lives, then this channel is worth your time. Subscribe, and let's keep exploring the difficult but necessary questions together. See you in the next one.